number is called an irrational number. Okay? Irrational numbers. And irrational numbers is a set of numbers that cannot be written as a fraction, right? And is represented by Q prime, all right? No. I will give you some examples of irrational numbers. So these are a set of irrational numbers, okay? There is Archimedes constant, the first constant, which is pi, okay? We have the next Archimedes constant, which is known as tau, all right? We have Euclid's constant, which is epsilon, okay? So we have pi, we have tau, we have Euler's constant, which is epsilon. We have the Feigenbaum's constant alpha. So these are the symbols for those. We have the Feigenbaum's second constant delta. We have the Apéry's constant, which is zeta function 3. Okay. We have the golden ratio, phi. Okay. We have epsilon, which looks like a U. We put it up here. Epsilon. We have gamma. Gamma looks like this. And we have omega. All right.
So which one are epsilon? I can't see the board on the board like that.
Sorry.
Wait about them.
Okay. So these are the values which are irrational, and these are only some. And the thing about these is that they have their own system. For example, there is pi over 2, there is 2 pi, there is pi over 3, there is 3 pi, there is pi over 4, there is 4 pi, and of course these can also go negative. So you can see how big this system of numbers is. Same thing with tau. You can have tau over 2, you can have 2 tau, you can have tau over 3 and 3 tau, you can have tau over 4 and 4 tau, and you can have the same thing with these. So you can have 2e, you can have e over 2, you can have 3e, e over 3. So these are far bigger sets of numbers than these, right? This is a huge, huge set of numbers. And then there is a secondary set of irrationals, which have their own branch of mathematics, and these are called surds. Right? And what surds are the square root of any non-perfect square. Non-perfect square. Okay? In other words, if you have a number, right? If you have a number, and when you square rooting the number, you find out it is not a perfect square, then it becomes automatically a surd. For example, root of 2, that's a surd. Root of 3, that's a surd. Root of 4 is not a surd because the root of 4 is 2. So that gives you a definite answer. So that's not a surd. But the root of 5, the root of 6, the root of 7, even the root of 8 is a surd. So it's irrational. The root of 9, not a surd, because the root of 9 gives me 3. And that is a definite number. So after that, you can have the root of 10, the root of 11, the root of 12, the root of 13, the root of 14, the root of 15. Root of 16 is not a surd because the root of 16 is 4. Okay? This here, irrational numbers, is a far bigger group than rationals. And the reason why these are not taught at primary school is because they're very complicated. So put your mind around that. When you try to calculate with them, this will never end. Pi, it only has the notice how pi is described in value. 3.142 that means that goes on forever and it does not have a pattern. In fact, I believe the last person that did it, I think, came up with almost 1 billion digits behind that decimal point for pi, and it never ever gives you the same number. It doesn't give you the same pattern. It just keeps going over.
When she